Okay, now we are continuing with our study of pollution in the environment. As you recall, we started with the water pollution, and now we're going to select another type of pollution from the source, like there's pollutants are present in the water that are also present in the air. We call this air pollution. If you take a look at the slide here, you can see the one major source of air pollutants is found in smoke. And as you see, can hear, for example, an industrial plant that uses a fuel. The fuel being either oil, coal, or gas. When it's burned, it gives off waste products, particles, chemicals that get into the air. Just like a car, when you start the engine up in most cars today, there are some electrical cars, which is something new, which we can talk about later, but right now gasoline is in the engine, and then when it burns, it produces an exhaust that comes out of the exhaust pipe. That's smoke as well. And if you analyze the smoke, it's made up of various chemical substances. We can take a look at some of them here. Since they're chemicals, there are formulas for these chemicals. Here is one now, SO2. S is an element sulfur, and oxygen, O is the oxygen, and they combine together to produce sulfur dioxide. Okay, this is a very common substance found in smoke. Also, nitrogen oxide is also present. This X means it could be any number of oxygen atoms. You could have 1 or 2 or even 3. The more common one is nitrogen dioxide. And so you have sulfur dioxide and nitrogen dioxide coming up into the air. And the air, of course, has moisture in it. There's clouds in the air. So what happens often is the sulfur dioxide reacts with the water. Oh, am I talking now? Oh, okay. And produces an acid called sulfuric acid. And the acid falls into the lake here, or the body of water. If there's a lot of it, it makes the body of water acidic. We haven't studied the acidity of the water, but we have a important situation here where the acidity is measured in terms of how many hydrogen ions are present in the water. The hydrogen ions, a very high concentration of hydrogen ions indicates a very high acidity. There's a pH scale, goes from 0 to 14. The lower numbers are the higher acidity. The average acidity, for example, of water is around 7 on the scale from 0 to 14. And 7 is found in most of healthy lakes and freshwater bodies of water. But when the acid enters the water, it changes the pH and lowers the pH to maybe as low as 5 and even lower. So the government has a standard for the pH quality of bodies of water, and it's set at a pH of 5. And if it goes below 5, it's defined as acid rain. So the hydrogen ions that come into the water, the H plus is the way we would write the ion, the hydrogen. And an ion is a charged element. Hydrogen can exist as uncharged, but in this one, when it's become charged, because it has lost an electron, it's become positively charged. And this is the hydrogen ion. And the number of these hydrogen ions in an environment indicates to what extent it might have be acid. So a high number of hydrogen ions in the water. And where do the hydrogen ions come from? They come from sulfuric acid. SO2, when it joins with water, it forms a sulfuric acid. And the hydrogen ion, the hydrogen part of the sulfuric acid, dissociates from the rest of the molecule and becomes part of the water. And you also can say the same thing for NO2, when it reacts with water, produces nitric acid. And nitric acid contains hydrogen ions, and they dissociate from the rest of the molecule, and as a result. So the combination of hydrogen ions from sulfuric acid and nitric acid, which are the two acids in the water, result in the acid increase in acidity of the water. And this has been happening in many places in the world today. So we have pollutants, and the origin of the pollutants are from smoke. Burning of fossil fuels produces the smoke. So if you want a cleaner atmosphere, you have to look for another way of generating energy other than burning fuels, and we're going to be covering that very shortly. So that's one example. There are many other chemicals in the air. For example, you may recall the mercury. Also, since this power plant may be using coal, and coal has a source of mercury, has a rather high amount of mercury as compared with other types of fuels. So when it's burned, it gives off mercury into the air. And mercury, of course, will come down as rainwater into the body of water, and you'll have mercury contamination of the water if you have too much burning of this smoke continuation. And here we can see examples of where the sources are. Factories, homes. We have this thing called carbon monoxide, which means one oxygen atom. So carbon monoxide is written as CO. You know of carbon dioxide, CO2, okay? And so carbon monoxide we have to be very careful about, because there are many accidents and deaths resulting from carbon monoxide poisoning throughout the year, a number of them. And some of it comes from the smoke or the burning of a fuel. If the home is not properly ventilated, that carbon monoxide accumulates inside, and what it does is it competes with oxygen, and it causes a deficiency of oxygen in the body, and it causes a poisoning, carbon monoxide poisoning, and death. And we have many examples over the years of famous people dying from carbon monoxide poisoning, as well as all peoples that are not careful about living in environments that are where you have a free exchange of fresh air. Very, very important. Wherever you live, in whatever building you're in, you need to be aware that the smoke that's outside becomes inside. So you have to open windows, you have to have some kind of air conditioning system going, or some kind of airflow, so that the interior of the building is safe from air pollutants. So carbon monoxide is another air pollutant. Actually, carbon dioxide can be an air pollutant. And some of these chemicals, it could be either way. Carbon dioxide under average amounts in the air, which is much less than 1%. The content of CO2 in the air is much less than 1%. But that less than 1% is extremely important, as you remember, in photosynthesis, because it's taken up by green plants to make food and oxygen. However, if you may recall, when there's too much CO2, well, we'll be talking about this in more detail later, but if there's too much CO2, it accumulates in the atmosphere and acts as a barrier, a blanket, really, around the Earth, which prevents the Earth from releasing its heat into the atmosphere. So it traps heat. So CO2 in very high amounts traps heat, and it results in a condition, a very important condition which many of you know about. We're going to be looking at it in detail later, global warming. So here we have examples of chemical substances, harmful substances, pollutants coming to us from the air. Whoops. And you can see this little cartoon here. Not a big exaggeration, because the CO2 that accumulates in the atmosphere comes from the burning of fuels. And since we're talking about the atmosphere, which is a layer of gas approximately 200 miles high from the surface of the Earth all the way up into space, and there are different layers, and one of the layers is called the ozone layer, and this is in fact called the ozone shield. Now ozone has the formula O3, very similar to O2. Okay? And when it's in the atmosphere, in the upper atmosphere, it's a very, very important layer of gas that actually absorbs excess amounts of ultraviolet light, preventing too much ultraviolet light from reaching the Earth. We need a small amount of ultraviolet light in order to produce vitamin D inside of our body. Small amount is required, but a large amount can result in cancer of the skin and very harmful effects on the body. So here you have an example of ozone, which acts as a shield which protects the Earth from excessive amounts of ultraviolet light. However, a number of years ago, and still common in some parts of the world, we use the spray cans. There is and any spray can that you use, when you press the nozzle, it sprays out. There's a chemical inside called a propellant. And the propellant has been used for a number of years. That we've used is called chlorofluorocarbon, or CFC. And we have it down here. And we found out that CFC actually moves up into the atmosphere and gets into the ozone layer and breaks down ozone from O3 into O2. So CFC acts as a chemical substance that creates oxygen from ozone. And you're saying, well, that's good oxygen, isn't it? Yeah, but oxygen does not absorb ultraviolet light. Ozone does. So in the upper atmosphere, ozone is extremely important. And so they found out that the CFC is in the propellant. So guess what happened? We banned the propellant, so we don't use CFC anymore. Other chemicals are used as propellants, but not CFC, because they found that CFC does break down the ozone shield. So here's an example of how science uses, even though we had this pollution going on and we weren't even aware of it, but new developments, new research by scientists, and this happens all the time in science. Science is solving problems about our world, and some of the problems that come up are very, we have fortunate outcomes like this one. So we don't use CFC anymore. There may be other countries that do still use it, but we don't. And so we're protecting our own ozone layer, at least in the northern hemisphere. And also the southern hemisphere. But what happened a number of years ago is we found the holes were mostly in the southern hemisphere. Now, keep in mind that ozone is normal in the upper atmosphere, but every once in a while there's an accumulation of ozone at sea level. And during the summer in particular, when it's very, very warm, the ultraviolet light that gets through in the presence of other pollutants causes oxygen to break down into simple oxygen atoms. And these loose oxygen atoms join together with the oxygen gas to create ozone. Only under polluted conditions during the summer when it's very hot and warm. In fact, weather reports will talk about ozone warning, especially to a lot of people who like to run along the shore and along the highways, where you have the combination of pollutants from the car plus ultraviolet light plus high temperature. That combination of factors creates a breakdown of O2 into single oxygen atoms, which join with the oxygen that's already there to create ozone. Now, ozone at sea level is very, very harmful to the lungs. It destroys the cells of the lungs. It irritates the cells of the lungs, and and considered a toxic substance. So here you have another example of a chemical substance that could be either good or bad, depending upon its concentration. CO2 is good in low concentrations, bad in high concentrations. Ozone is really important when it's up in the upper atmosphere, but when it's at sea level, it's very harmful. So we have a case of most of us spend most of our time indoors, and if you look at this picture here, you might ask, different rooms, bedrooms and living rooms, basements in some cases. Which area do you think might be not as healthy to live in a house like this, which it has basement, first floor and second floor? And if you look carefully enough, you'll see that there are windows in all these other rooms here. And these rooms have windows, not so you could look out, so you can open them up, so you can get some fresh air in there. But a lot of basements either don't have any windows or very small windows. The result is there's very little airflow. And so there's very little ventilation in the basement. So if you live in the basement, you need to be concerned about the airflow inside. And the reason for that is that there are many basements, and especially the older buildings, were built on foundations of stone. And the stone contains these elements called radon, R, capital R, small script letter. When they write these elements, and there's more than 2 letters, the first one is always printed high, and the second one is always script. So that would be the symbol for radon. Now, radon is a radioactive element, which means it's unstable and it releases radiations. And some of these radiations we have in an environment a normal amount of radioactive substances and radiations in the environment, which is perfectly normal. But if you live in a confined area and you're surrounded by rocks, material that contains radon, the radon concentration might be higher than, will definitely be higher than normal, especially in unventilated quarters like the thing here. So from time to time, they have examples of a high incidence of problems with the lungs, and particularly even some lung cancer resulting from the accumulations of too much radon inside these confined, unventilated units. And the reason then that what we need to do is ventilate area, open up the windows, have some airflow inside. That helps a lot. The result of all of this, of air pollution, is it affects our lungs. And here you have a case of someone holding his nose and taking in oxygen. Why? Why is he taking in oxygen? Well, he happens to have a condition called asthma, as you can see here. And in asthma, there's an irritation of the air tubes inside the lungs that actually, instead of being of a normal size that carry air back and forth, they're much smaller. Something got into the breathing, into the lungs, that caused a contraction of the bronchioles, the air tubes that carry oxygen into the lungs. And so he's taking in a source of oxygen and holding his nose because he really wants to get the oxygen, and he doesn't want to get air from the room itself. So it's very, very common in certain areas of the country, particularly in cities. Asthma is greater in cities than in the country. There are more asthmatics that live in the cities and towns. Why is that? What's the difference between the country and the city? Again, we have to look at the environment, and we get to more cars, more shops, more industry, more burning of coal, fuel, gasoline, and oil, and therefore the production of more smoke. It's smokier. And here we have a case of a comparison of different groups. If you would look at this, we would find out which group is very, very high. And according to the chart here, if you look at it, you can see the age 5 to 14 has a much higher incidence of asthma. And other groups are lower, still asthmatic, because it still contains, the air still contains contaminants. But the interesting thing here is 65 and older. This is the lowest group here. Has the least things, these elderly people. Why is it that the group 65 and older have fewer examples of asthma than the younger ones from 5 to 14? And you may have some various speculation on that. You want to think about that. What are the conditions? Why would one, usually when you hear about the elderly, you hear about they have more life-threatening ailments than children do. And so that would lead you to believe that maybe they're more susceptible to asthma, but they're not. And obviously from the data here, so you really want to take a look at the condition, the environment, and where and the history of the person. So you can speculate on that. You may have noticed that these slides, like in previous lessons, each slide contains a question or 2 or 3 related to the slide itself. We've put all these questions together at the end of the presentation, and it's extremely important for you to answer these questions. They are part of your homework assignment,